Hello, I am Judith Hurwitz. I am the Chief Evangelist here at Geminos, a leader in causal inference, causal AI. And it is my pleasure to introduce our speaker today, Paul Hünermund. He is the Assistant Professor at Copenhagen Business School and a research expert in causal inference. And he is also the organizer of the annual causal data science meeting that is in its third iteration. And I'm sure that we'll be talking about the fourth, fifth, and sixth over the years. So it is great to be with you today. Now you have been doing a lot of work on focusing on the adoption of causal inference tools in the industry. And I believe that the timing is really important for that because we're beyond the era of where we're thinking about causality and causal inference. And now we're looking at, okay, how do we use causal AI, causal inference to solve real business problems in the industry? So we were talking earlier about how important it is to apply these methods to real problems and looking at it from the perspective of the bottlenecks that are there that need to be solved. So maybe you can start by talking a little bit about how you see this from a market perspective.
Yeah, thanks, Judith. Thanks for having me. It's really great to talk about my research and my perspective on causal AI. So what we try to do is sort of understand where the industry are, where sort of data scientists, but also key decision makers, executives in industry, what the problems is they're struggling with, and the bottlenecks they face. And what nutshell our results is that causal AI seems to be still in an early stage of adoption. So there's lots of buzz and hype around it. But people still sort of struggling to understand what is this new paradigm shift that they're faced with and where it might be leading. And frankly, there's also sort of missing skills in that area. Causal AI is not something that is taught in many curricula at the big universities, but that seems to be slowly changing. And I mean, we know that developments can happen fast in this space, especially in machine learning and AI. So we really see a positive outlook for these kind of methods and this kind of technology.
So Paul, is that related to the adoption of open source technology that is helping to accelerate that?
Yeah, definitely. So I mean, we have big players now investing heavily in that area. And I mean, first of all, people take note of this, and it's sort of a guiding example for others to follow. But then, of course, once you start out, you need to find the right tutorials, you need to find the right tools to work with. And that is key. I mean, we see more and more libraries in programming languages like R and Python coming up, but other tools being developed as well. And that really helps people to get hands-on experience with these sort of tools.
Excellent. So let's talk about the bottlenecks and how you see things changing in the industry.
Yes. So we try to understand sort of where is this coming from? Is it a push from management? Is it more like bottom up? And it seems to be the latter. So perhaps driven from academia into industry. So data scientists take note of this. Probably the publication of the Book of Why in 2018 also gave a big push. The Book of Why by Judith Hurwitz and Dana McKenzie gave a big push into this. And yeah, so then what we saw is in the interviews that we did, and we run surveys with data science experts, is that there seems to be a small group of dedicated specialists within organizations that are pushing this topic, and they're really seeing the need for it. Sometimes because they see that the questions that they're faced with are inherently causal. So like they get asked as data science experts questions that have some form of causal component. But they also realize that it's actually really easy to explain at least the fundamental concept also to executives and people that are coming from the business side. But then, of course, all this needs to be translated into sort of the right set of methodologies. And there we see sort of still a mismatch. So we talked, for example, with consultants in that area, and they have sort of a broad overview of clients that they're working with, and they told us that they think that the majority of questions they're faced with are causal, but the kind of tools that they are trained in, but also that people might understand and have heard of, are mostly correlation based, and there's a mismatch that frustrates data scientists, but also, of course, then the clients on the other side. Because
is one of the problems, Paul, is that a lot of conventional wisdom in AI is if I just have enough data, I can figure out anything. Do you see that as one of the big problems that has frustrated AI specialists?
Yeah, definitely. Like, more and more data, right, will solve our problems. And we know from, theoretical concept like the ladder of causality, that is not the case. And people start to realize this. But it starts already earlier. You don't have to become fully philosophical about it, right? It's just asking the right question for my business problem at hand and choosing the right tools in order to answer this question. And like people like resort to the kind of tools that they're taught in school, right, for example, or the kind of methods that they're used to, and most of them are within a correlation sort of associational framework, and that just creates lots of frustration for these people.
So talk to me about some of the use cases, the way you're thinking about applying causal inference, causal AI to business problems.
Yes, I mean it's the big problems that have that were out in AI for centuries. No, centuries is a bit much, but decades. One of them is obviously explainability, right, and interpretability. And referring back to the ladder of causation, we know Nancy Cartwright had this adage saying, "No causes in, no causes out." So you need some form of causal model, if you want to call it like this, or causal assumptions, right, that are untestable. And there comes the perspective of more data won't help you to answer these kind of questions. So you need some form of background knowledge that you bring in. The answers that you get out depend on these kind of models or assumptions that you make, but then it becomes much easier actually for a human also to understand this pipeline from data assumptions to the final solution. You can probe the robustness of these recommendations that the system gives you based on the inputs that you give to the algorithm, and that just adds a layer of interpretability that a black box sort of deep learning algorithm could never achieve. So that is definitely one, and that plays a huge role, right? So in some of the interviews, we got responses. I mean, trust is an important component if you give decision authority to algorithms and machines, and that also determines, I mean, the level of trust that you put into them determines how much decision authority you will eventually grant. So explainability is sort of an antecedent for data augmented decision making. That is one result that we found in our interview and survey studies.
So walk me through a use case in sort of in the real world. Pick any industry that you think will give people an idea of how you apply causal AI in the real world.
Yeah, so let me choose an example maybe from another pillar of or one of the main challenges that AI face, and this is well, transportability, or social scientists like myself would call this external validity. And this is an application. So one of the main methods, I think one of our respondents called it the big hammer that tech companies swing, is A/B testing, right, and experimentation. And that has a lot of advantages also from sort of the explainability side, because an experiment is easy to explain also to non-data scientists and so forth. So many companies have adopted this, especially in the sort of e-commerce and online world, because there it's low cost to experiment, for example, on a website feature. But that gives interesting sort of the ability to do that gives interesting questions about like what kind of experiments, A/B tests you should be running, and who has the authority to run these tests on the platform, and then what we found is that simply like users of A/B testing, they can be actually overwhelmed by the possibilities of A/B testing. Simply the amount of hypotheses that you could possibly test is vast, is theoretically infinite. Especially because we know that most of these tests, they're very incremental. It can be, you know, a shade of blue on a website, or the shape of a button, and sometimes that can have huge effects on clicks, for example. But how do you choose these tests, and how do you do that in an efficient manner? And there, transportability, I think, can play a huge role, because the causal AI allows to build on this experimental base that you accumulate over time, and for example, reuse tests that you've done in the past in an efficient way by incorporating these kind of causal models, and to answer questions that you have nowadays. So just very briefly, maybe one of the situations that our respondents talked about is the COVID-19 pandemic, and the question about maybe you've accumulated lots of experimental knowledge before the pandemic or during the pandemic. Now we're slowly moving out or into sort of a new normal. The question is, has the world changed so much that we should sort of discard all this experimental knowledge that we've accumulated, or can we somehow productively use that? And in the past, the answer was most of the time, let's just rerun the test, right? And that, of course, creates sort of an infinite loop about rerunning tests on a continuous basis. With causal AI transportability techniques, you can design that in a much more efficient way.
So how would you recommend people begin to do that? To first model the problem and then select data? How would you approach that?
Yes, so that's a general theme in causal inference, right? So you need to bring in not just the data, but also background domain knowledge about the topic that you're studying. Yeah, so the question is, where is that coming from, right? You can go a fully sort of theory-driven way, which means you bring in domain experts from, let's say, marketing, if that is the domain that you're working in, or from the production side, and just try to get these causal assumptions that are fitting to the problem at hand out of them, and that gives interesting challenges for sort of organizational design, because like, how do you structure that in the most efficient way? But there are also possibilities to use at least data augmented techniques, causal discovery being one that can support this process. But in the end, you need to come up with a causal model of the phenomena that you're studying. And in the example that I've just used with the COVID-19 pandemic, it would be that you need to have expertise, domain knowledge about what has changed in the meantime. How is your user base reacting perhaps differently now than they did during the COVID-19 pandemic, where traveling was limited, business traveling was subdued, much lower. So you will have, for example, simply a different customer base that you're facing, and you have to incorporate these kind of qualitative assumptions or qualitative knowledge about the differences in the domains in order to carry out such a study. I will say, though, that this sounds now perhaps a bit intimidating, because how can you actually know, how your user base has changed over the last, let's say, 12 months? The good thing with many of the causal AI techniques that we have these days is that you don't need, for example, like an exact quantitative measure of these differences. Simple qualitative assumptions are good enough to capture these differences, and the rest can be augmented with answers that you get out of the data itself.
So it's really incremental and iterative. You learn something, you apply it to the model, you add data, and then you iterate as you learn more.
Exactly.
Good. So what do you see as sort of the next milestones in a causal AI?
Yeah, so we talked about tools that are developed more and more. I think the landscape is still a bit scattered, and like I was talking about someone that freshly wants to start out and get into this topic, I think at the moment it would be still sort of hard to see which tool to look in first. More combination and aligning approaches, also just simply like the way libraries and software tools are structured, right? Like they all have currently different design philosophies. So combining these tools, I think, would help. Another one is simply, seeing more educational material, right? Like online tutorials that people can at least start out with. We have more and more great textbooks in causal inference that are also suitable, let's say, beginner level would be a bit much, because none of these techniques are really beginner level, but let's say someone with a decent statistics background or data science background could start out with. I think finally, just because causal inference is very interesting because it affects so many domains. It's almost like a general purpose technology, but that means that there are also many different fields, scientific areas working on that problem, having their different languages, different vocabulary. So that simply this sort of translation task seems to be a bottleneck. And that was one of the main reasons why we established the causal data science meeting, bringing together people from different scientific disciplines, but then also data scientists from industry, in order to get just a conversation going and get people starting to talk to each other. That I think is very beneficial.
Excellent. Well, thank you so much, Paul. It's been an excellent discussion. Look forward to continued dialogue.